In this video, I will be working out the section 8.2 day 1 notes. We're talking about adding and subtracting rational expressions. And the same rule is going to apply to adding and subtracting rational expressions as it does to fractions. In order to add or subtract, we're going to need to have common denominators. You cannot add or subtract rational expressions without that common denominator. So in problems 1, 2, and 3, they are going to give us those common denominators. So this is going to lay the foundation for the problems for today. When you have common denominators, all you have to do is follow the operation for the numerators. For example, number 1, 7 plus 3 is 10. But you keep the common denominator of 4x, and then simplify the fraction. So when you add or subtract, if the denominators are the same, go ahead and work with the numerators, 2x minus 5, but keep that common denominator the same. And you'll notice here that nothing's going to simplify. Those are completely different binomials. Problem number 3, 4x minus x is 3x. All over the common denominator. And once again, nothing is going to cancel. Now, if you have unlike denominators, you will need to find the lowest common denominator, which requires you to find the least common multiple. It's two different ways of saying the same thing here. So if they say to determine the lowest common multiple of each set of polynomials, that's the process you use to find the least common denominator of a fraction. Now, I will say that you don't necessarily have to find the least common multiple or the least common denominator when you're working with rational expressions. As long as it's a common multiple, it'll still work. You'll just have to reduce your answer even more at the end of the problem. So the word least here, it's good to know that because that's going to be the most efficient way to do these problems. But if all else fails, you can still just find a common multiple and then just reduce your answer. So here it's practice using and finding the least common multiple. So if I have two numbers, two variables, the least common multiple is literally just x times y. I just multiply them together. Over here, I could take just 2x times 3x and get 6x squared, but 6x squared would not be the least common multiple. It would just be a common multiple. Since they already have the x in common, I don't need it. All I have to do is take 2 times 3 and get 6, and then keep the x, which is already common. So I don't have to do the repetition. So if you look here for part 3, I have x to the third x squared, so that means I'm going to need an x to the third at the very least. And then for the y's, I'm going to need a y squared. So they are specifically asking for the least common multiple here, so I have to have these answers. But, over here, or even in these problems, different powers would be allowed as common multiples. Now, number 4 is a really important note to make here. X and x plus 4, two different expressions. The least common multiple would just be x times x plus 4. Those are two different polynomial expressions. We don't know what x is, so I have to have both. The only time where it works out for a problem like number 3 are the powers. Notice there's no adding or subtracting here. These are monomials, but here I have a monomial versus a binomial, a little bit different. So number 5, you might be thinking, hey, I've got x squared minus 25. That's a binomial, and that's completely different than this binomial, which is x minus 5. So should I just multiply them together like in part 4? And if you did that, that would be a common multiple. It just wouldn't be the least common multiple because x squared minus 25 is a difference of squares. So this first term already has two factors. And you'll notice that the x minus 5 is already in common. So I don't need to list it twice. So I would just list the x minus 5 once, very similar to how I only listed the x once up here. But then, of course, I'm going to need x plus 5 as well. Number 6, I have 5x, and then I have 5 times x minus 4. You'll notice that I'm factoring here because when I factor, I can see what common factors they might have. And you'll notice that here the common factor is 5, so I list it once. Now I need an x, and I need an x minus 4. And so for this last one here, I have a difference of squares. And then here I have a perfect square trinomial, x plus 3 times x plus 3. Now, x plus 3 shows up twice here, just kind of like y squared showed up, y to the second. I needed that higher power, so I'm going to need x plus 3 twice. At the very minimum, I'm going to need it twice, but I'm going to need an x minus 3 as well. So that's the work with finding the least common multiple, and this is going to help us to find the lowest common denominator. So there are some steps here that you can follow to add or subtract rational expressions that don't have common denominators. Read over that. Pause the video if you need to. I'm going to flip to the back. So, problem number 1, I can clearly see that they do not have common denominators. If you want to, somewhere off to the side, you can say, hey, what would the common denominator be for this problem? And I'm finding the least common denominator. Between 3 and 4, the least common multiple would be 12, because that's 3 times 4. And then if this is an x squared and this is an x, then I'm going to need an x squared. Now the reason why I write this off to the side is so that way you can see how I'm going to change each fraction. For example, to go from 3x squared to 12x squared, all I have to do is multiply by 4. But I have to multiply that in both the denominator and the numerator to keep the fraction balanced. From 4x to 12x squared, I need to multiply by a 3x. So a lot of times you'll see people do this work, and it can get kind of busy if you write all of these numbers on top of each other. But this is the work to get the denominators to be the same, because if you look now, I have 4 times 8 over 12x squared minus 15x over 12x squared. My denominators are the same, so now I just go ahead and subtract 32 minus 15x, which you can't do anything with that, all over 12x squared. Now, if there was a GCF that I can take out of the numerator, I would want to do that. If there was a GCF of 2, then I can cancel with the 12. But this is a binomial, so there's not a whole lot I'm going to do there since it doesn't have a GCF. So it's up to you if you want to write out the lowest common denominator each time or just kind of go for it. For example, number 2. First thing I'm going to do is I'm going to factor the denominator because I want to see what it has in terms of its factors. And a lot of times, I just cross off the part that I've factored. I don't need that part anymore. So I'm going to write the factors right below it and then cross it out. So you can see that they already have a x minus 3 in common, but the second fraction is going to need an x plus 8. And so the way that I'm going to write this out, I'm going to write 12. And then I'm just going to write the common denominator once. Instead of writing it twice, I'm just going to write it once. So plus 3 times x plus 8 over x plus 8, x minus 3. You need to distribute the 3, combine like terms. So this would be, and I'm going to do this in one step, 3 times x is 3x, and then 3 times 8 is 24, 24 and 12 make 36. Now, you need to go ahead and take out the GCF from the numerator because there might be a factor that can cancel with one of the factors of the denominator. It doesn't happen in this particular problem, but there's a chance that maybe instead of x plus 12, it could have been x plus 8, and then those could have canceled. So if you see the possibility of a GCF, take it out. But once again, I kind of combined a few steps there because I did the distribution with the 3. That was like 3x plus 24. And then I added 12 to that to get the 3x plus 36. All right, number 3. I have to factor the denominators. So the first one is 2 times x minus 1. The second one, x minus 3 times x minus 1. And I'm going to cancel out the denominators. All right, so it looks like this first fraction is going to need x minus 3. The second fraction is going to need just the 2. So I'm actually going to throw that out front right here. And then that's all over the common denominator. So you're going to clean up the numerator now. And sometimes you might see some notation here. Like I could keep working out this problem with multiple steps. I don't want to write this denominator every time. So I could do this just as a placeholder so that way I don't have to keep writing it. And then I'm going to clean up the denominator, or the numerator, excuse me. And then it looks like I can factor the numerator. And this is where I will want to put the common denominator back into play. And here's that example of where things actually do cancel. And so I'm just left with x plus 4 over 2 times x minus 3. We're going to do one more here, and then I'll show you the answers to the last few if you want to see them. Number 4. It looks like the first numerator doesn't, or first denominator doesn't need factored, but the second one does. All right, so I'm definitely going to need an x plus 1 over here for the first one. But the second one, and I'm actually going to wait to write this x. The second one needs to go to 9, and it already has 3, so it's going to need an extra factor of 3, because 3 times 3 is 9, but it's going to need an extra factor of x as well. All over the common denominator, which would be 9x squared times x plus 1. So then I'll go ahead and clean this up. And then I would rearrange the numerator. And I don't think that factors. So then I'm just going to put the common denominator back in. Since it doesn't factor, there's nothing that's going to be able to cancel. And there you have it. All right, so if you want to pause the video to try these 3 problems at the bottom, you certainly can. I would highly advise looking at number 6 before you stop the video. But probably the other ones are very similar to what we've seen so far. So pause the video, try these out if you want to, or just take a moment and look at what I've got on the video. And the reason why I starred number 6 is because the common denominator is x minus 4 to the second power. So once again, hit the pause button if you need to. Go ahead and look at those and let me know if you have any questions. But that's it.